Okay, we will continue the problem. So the question was to calculate the base shear and the design lateral force at each floor. So the first part we have completed. Base shear is calculated. So how much was the base shear? Base shear has come as 1188 kilonewton. Okay. So the second part of the question is design lateral force at each floor. Force at each floor. So you can see here the distribution of design forces. Design forces. So what is the equation for how do you distribute the base shear to each floor according to the height of the building? According to building. So the equation is Qi is equal to VB into Wi Hi square divided by sum of Wi Hi square, where Wi is the and Hi is the height, the base to the floor, base to the floor. Okay. So using this, table now. You can create a table with story height, story level or story. So story level can be, this is the fifth one, fourth story, third, second, first. Okay. Then weight of each, seismic weight of each. Can you tell me what was the weight at the fifth floor? How much it was?
3,000.
3,000. And for remaining all the floors, it was 4,000.
4,200.
Isn't it? So 4,200 for all the floors. The next is the height. H height. So how do I write now? If I start from the first story, what is the height?
3.5.
It was 3.5, isn't it? 3.5. When it goes to the second floor, the height should be
3.
from the base to the second floor.
Both, ma'am.
It should be like this. This is 3.5. The remain second 3.2, 3.2, 3.2.
6.7.
To this level. That is the meaning of the second floor height, H. So 3.5 plus 3.2. How much? It is 6.7. 6.7 plus 3.
9.9.
9.9. 9.9 plus 3.2.
13.1.
3.2.
13.1. 16.3.
13.1. 16.3. So the total height of the. So this is the height. Okay, this is how we should write the height. Hi is measured from the base. Now what is the equation for you? You have at the numerator Hi square. So the next column is Wi into Hi square. So each term you can multiply with the square and write down this, and the end of it we can sum it up. Sigma Wi Hi square. Now what is the base? This is one. Q is equal to VB into the base shear into Hi square divided by sigma of Wi HI square. Okay, so this is the distribution of lateral force. You multiply 3000 with 16.3 square. Each one you write, sum it up. Q is equal to base shear multiplied by this term divided by. Okay, so please tell me the answers. Please do the calculation. Tell me the Q value. Q value, I'll write it here.
Ma'am,
Yes.
so our fifth floor Q value, I'm telling ma'am, is it correct? 436.47.
I don't tell me.
436.47.
436.47.
Is it correct, ma'am?
Is that right? Did you multiply with the base shear VB?
Yes, ma'am. 1188.
1188 multiplied by what is it? WHI square is. Did you calculate all these things?
Yes, ma'am.
Tell me, first one.
797
Ah,
070.
797
070.
07070. Correct. Next one.
720
720.
762.
Ah,
762.
76. Next one.
411
411
642.
64.
188
188.
538.
Ah,
538.
538.
51
51
450.
450. Sum of all this.
Ma'am, I'll check it again once, ma'am.
Yes. Write the sum. What is the total sum?
Total
Ah,
2169
2169.
Ma'am,
Tell me.
2169.
Some.
Yes, ma'am. Summation value.
Okay, 79070.
2169462.
2169.
462.
Is there any other answer? You can tell me. This is a summation of these 5 values. 1, 2, 3, 4. These 5. Is it correct? Then your first value will be Q base shear 1180 multiplied by this 070 divided by 2169462. That is how you have to calculate. Q is equal to the base shear 11 multiplied by the first value WIHI square 790070 divided by the summation 169462. If the answer is right, I don't know. You have to check the answer. How much? $36.47. Correct. And then second answer
394.69.
3939.
4.
Ah,
0.69. 69.
third one
225.
225.
0.41.
Fourth one
103.
103.
0.24.
24. Last one
28.17.
28.17. Can you sum or can you add all these values and tell me how much it is?
Yes, ma'am. 1 minute, ma'am. Ma'am. 1187.
1187.
0.98.
Okay, finally. Okay. 1188. Okay, 1187 point something will come, or 11. So what is the meaning of this? That 1188 that you have obtained is distributed to each floor level as this much kilonewton. This much. Okay. So this is how it will be finally. It will be coming like this. Each floor level, how much to the first floor level? It is 28. Second floor level it was how much? 103. Third level it is 225. Fourth it is 394. And at the fifth floor level you have 436. Now when you this is the lateral force that is coming at this particular residential building at each floor level. This is how you calculate the earthquake load. Is it clear?
Yes, ma'am.
In your StatPro or whatever software what you are using it, you can analyze it, or manually if you are doing calculations, there are different methods, substitute frame method, cantilever method. In structural analysis, you must have learned how to analyze structures for lateral loads. Okay. So to find out the lateral load, this is the one method for that is a static analysis. Is this point clear to you? Did you understand how the earthquake loads are calculated at each floor level using static method of analysis? Is it clear? Is this part clear to you, all of you?
Yes, ma'am.
Yes, ma'am.
Okay. So this particular method, we call it as response spectrum method also. Response spectrum method. Okay. The static method of analysis, equivalent static method analysis, we call static response spectrum method. Okay. Or simply static analysis. That means we analyze that in this, we are not considering any no time in different variations or the mode participation. Nothing is considered in static analysis. It is just assumed that the entire dead load and live load is lumped at the particular floor level, and that using that and the height of the building, the earthquake load is calculated. This is the static method of analysis. Okay. I hope it is clear to you. Now we'll go back to the question again. In the question, there was a second part. What is the last question? Can anybody read the last sentence? Please read the last sentence of this question.
If the building is converted into a hospital building, comment on the base year.
Same building, it was a residential building. Now, if this is converted to a hospital building, comment on the base year. So tell me, where will be the difference in this particular, and how the base year will be affected, whether it will increase or decrease. You have to tell me. Tell me what will happen if this building is converted into a hospital building. The base year. Just tell me what change will happen when it is converted to a hospital building on the base year.
Importance factor will be changed.
Okay, very good. Okay, so the importance factor will be changing from 1 to 1.5. Okay. Okay. So the importance factor will be how much it will be. Instead of 1, how much it will be? I. It will be 1.5. Now tell me, because the importance factor is increasing, how it will affect the base shear? Decreasing. Kaviyarasu. You please tell. I will not tell. You tell me the why. What will happen to the base shear? Now, if there is no response, I'll just close it and leave it. That's all. I don't know, because you just tell me. If there is no interaction, then there is no meaning of class.
AH value will become 0.1, ma'am.
Which one?
AH, ma'am.
AH. Okay. No, my question is, you can tell me whether the base shear will increase or decrease. When the importance factor is increasing, how it will?
Base shear increases, ma'am.
Ma'am,
Yes.
ma'am, only I value will change, ma'am.
Only I will. Tell me, anything else will change in this?
I'll check, ma'am.
Huh?
Ma'am, I will check, ma'am.
You check, because the question residential building we have completed. Now the last part of the question is, if the building is converted into a house, comment on the base shear. So you told that importance factor will change. Good, correct. And any other parameter will change?
Ma'am, whether the live load will be same, ma'am.
No. I am not saying live. Naturally, live load, dead load. I'm not mentioning about that. In this particular problem, naturally, your live load, dead load, and all will be. We have live load has to be increased, but that is different. Only comment on the base the building is converted into a hospital building. That's all. I am not touching the dead load, live load part of it. That is different.
Okay.
For the same dead load and live load.
Ma'am, we have to check whether the AH value, that only no, ma'am.
Age.
Up to that part.
Age. Which is the changing parameter? What you told is correct only. Your importance factor will change. That's all. Correct. Z will not, because the same Mumbai. SA by G will not change because the same plan dimension. Right. R value will not. R value, if you want, you can change it. Otherwise, assuming it's again a moment resisting frame, you can assume that is the same. But importance factor will change from 1 to 1.5. So all other parameters remain same. So because of the change of I value, my question is that it will increase or decrease?
Answer 0.1, ma'am. Increase, ma'am.
Okay, so without even calculating base share is W. What is AH? Z into I into SA by G by 2R. So I is again in the numerator.
Yes, ma'am.
AH will increase. When AH increases, your base share will increase, isn't it?
Increase.
Yes, ma'am.
So this is how you have to, because in any building, when it is converted into some other building, suppose if the location is changing, Z will change. If the building system is changed, instead of moment resisting frame, if a shear wall is installed or a shear wall construction is there in the hospital building, then your R value will change. Okay, my next, the importance factor remains same. Okay, the same residential building itself. My question is that, okay, listen carefully my question. Building remains same, but the system, I have been added 2 more shear wall into the system, into the structural system. So what? The same Mumbai, same plan dimension, same residential building, but when I renovated this residential, 2 shear walls into it. Okay. So what will happen to the base shear? Base shear will increase or decrease?
It will decrease, ma'am.
Correct. Tell me.
The reduction, response reduction factor will change, I think so.
Response reduction factor will change. Whether response reduction factor R will be more or less?
It will be more, ma'am. High.
It will be more. When your R value will change from 3 to 5. It will be more. Because when the R value increases, what will happen to AH value?
It decreases, ma'am.
AH will decrease. When R increases, AH will decrease. When AH decreases, what will happen to the base shear?
It will also decrease, ma'am.
Decrease. So base shear will decrease. So I just want you to understand what is this base shear depends on the location of the building, the importance of the building. Okay. So the height and the plan dimension of the building, the structure, whether it is a shear wall construction or a normal resistance frame construction or special or a braced structure or whatever it is. Okay, depending upon the type. Your base shear depends on all. So that is how the earthquake load is calculated at each floor level from the base shear. So I hope it is clear to you. This is what you should understand from this particular portion. How to calculate. It is not only to calculate it, you should understand the concept. If you want to reduce the base shear, modifications you have to make in the system. So that aspect you should be clear. Because let me tell you. So here we have given, you can see here the load combinations 1.5 dead load plus live load plus earthquake load. So it's only that. Okay, how to calculate this earthquake load? That earthquake load along with the dead load and live load combinations, you have to analyze the structure. You have to analyze the structure and you have to design the building. Is it clear? Can you see the slide now? Dynamic analysis.
Yes, ma'am.
So in dynamic analysis, there is a difference. A difference is there from the static analysis. Here, I hope all of you must have studied your structural dynamics. In structural dynamics, you must wait one thing. You must have learned about the mode shapes. Do you remember anything? Do you remember anything like this? Mode. Those who have learned structural dynamics must have learned about the mode shapes of the building. Do you remember anything? All of you must have learned dynamics, isn't it? I think Mickey has learned construction management. So he must be finding it difficult. All others must have learned it, isn't it? Dynamics. Yes.
Yes, ma'am. We studied, ma'am.
Yes, ma'am.
Yes, ma'am.
Or you don't remember? Just give me a reply so that I.
Ma'am, explain once, ma'am. So, with
Okay. Here, see here in dynamics, what we learn it is, suppose if you take a building, okay. So this part. One minute, okay. Ranjana ma'am, class class. I am in the class. For 2:30, I'll be free. Oh, mail, mama. Mail ID illada department இல்லையே அதானே தட்ஸ் ஓ அந்த அதுல இருந்து எடுத்து பண்ணலாம் ஓகே சரி ம் 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 ஓகே பை okay. So here any structure dynamics, as I was telling, dynamics means the structure will have a vibration. Okay, when there is an earthquake force that is coming, when there is a lateral force that is coming on a structure, that is due structure will have, okay, so the structure will vibrate and it will take some mode shape. Okay, I will not be able to teach you everything from the dynamics portion. First story, second and third. If there is a 3-story building, this structure will have 3 mode shapes. Okay, so this structure will have 3 structure. This is the first mode. The structure can vibrate into a single side. Okay, the second mode can vibrate like this. Okay, so this is called the second mode shape. And third, the structure can have, okay, so this is how a structure with a 3-story building can have 3 different mode shapes. It can vibrate. This is the first mode. This is the second mode, and this is the third mode. I hope you remember now at least. You must have learned the mode shapes. So similarly, if there is a 100-story building, into 100 modes, 100 different modes it can vibrate. Okay, so the main contribution, the frequency with which the structure vibrates is called the fundamental frequency. You must have learned the fundamental frequency. So using that, with that frequency, the structure will have a vibration. So that vibration factor, the contribution of this vibration will also be considered while calculating the dynamic analysis or doing the dynamic analysis. So that is what here I have written here, participation factor, or this is the mode factor. Okay, mode shape factor, this phi ik, this phi represents the mode. This phi represents mode. So this is the first mode. This is the second mode, phi 2, similarly phi 3. So everything will have everything. This will have a values at each and every. This will have a value. This will have a value. So similarly, at each and every flow, when the system vibrates or when the structure vibrates, there will be a mode participation factor. Also will be taken into consideration when you do the dynamic analysis. So the previous analysis, static analysis, we ignored everything. We don't go much details of the mode shapes factors and all. The previous analysis, all the loads, all the weight is dumped or it is concentrated on the floor level, that's all. But in dynamic analysis, along with that, you will be considering the mode shape. It's the vibration aspect, the dynamics aspect. Everything will be taken into consideration when you calculate the earthquake load. That's all. That is the only difference between dynamic analysis and static. So here, the first things, the participation factor, everything is just calculated. You just see the third step. You see the third step. The design lateral, each mode is calculated as this equation. If you compare with the previous equation, this equation, if I compare with the previous equation, what was the base shear? Base shear was equal to AH into W, isn't it? AH into W. Now compare this equation and this equation. What is that? In this, the base shear is AH into W. Here, if you see, the lateral force is equal to, this is common. Instead of AH, it is taken up. That's all. W is there. That's also there in the previous equation. So which are the two additional terms that has come here? Phi ik and pk. Okay. Phi mode shape values and p is nothing but the modal participation factor. Okay, you don't have to see much of this. All these things you must have learned in dynamics, but at least understand this. Analysis with weight, only the weight part of it and the horizontal. But here in a dynamic analysis, there are two more additional factors are there. Factor value and the participation factor value. When you multiply everything, you will be getting the design force or the base shear in dynamic analysis. That's all. That is the main difference. Is this understood? What is the difference between the static analysis and dynamic analysis? The static analysis, we consider only the seismic weight of the building. Dynamic analysis, along with the seismic weight, we consider the mode shape values or the participation factor. Is it clear? Understood?
Yes, ma'am.
So this we can do a problem, but it is difficult. Online classes, that is to entire problem. I will scan it and send to you. Okay, I'll scan it and send the entire problems to you, and you can go. Okay, a dynamic analysis problem, I will do it. I'll scan it and upload it in your MS Team. Through that, once that answers are with you, I can discuss that in the next class. Okay. Is it clear?
Okay, ma'am.
Okay. So this is what all about your earthquake loading. Okay. So the next one is the wind loading. Again, we have discussed what is wind. Is the horizontal movement of free air. Like earthquake loading, this also plays an important role in it exerts loads on the building. Similar way, your wind loading also has to be calculated. But for wind loading, you have what is the code for wind loading? Which code book you have to refer? IS. Please note it down. For wind loading, you have to refer IS 875 part 2. Okay. So this also has to be circulated. Everybody should have this wind load coding. So based, again, the wind effects can be, again, it can be static and dynamic. The static wind effect causes bending and twisting, whereas dynamic, tall, long span, slender structures, a dynamic analysis of the structure is essential. So there are many wind loading. Okay, there is a term called gust. Okay, wind gust is nothing but a high speed wind. A high speed wind which can cause fluctuating forces on the structure, which induces large dynamic oscillations. Okay, so in wind also you have static analysis and dynamic analysis. The code book gives you the information about static and so these are the forces that is generated. Because of the wind load, a tension force will be generated, a compression force will be generated, a shearing force can also happen, a torsional moment can happen. So all such different forces can be, it can happen in a building due to, okay. So the wind loading is very essential. Wind is the predominant. Okay. Earthquake need not be earthquake load. It is not only, it is not with respect to the tall structures. A low rise building and a high rise building. Okay, if it is for a high rise building, the damage will be heavier, that's all. But whereas wind loading, the tall structures are much affected, or wind loading. So that wind load calculation is also based on the IS 875. We can calculate the wind load and can be, the analysis can be done. Okay. So the next class we can do some problem wind loading. So these are the wind tunnel testing. This is the wind tunnel testing we have to do before you construct any building. The building has to be wind tunnel where the entire atmosphere is created in the wind tunnel. You can see here this red color is the building to be tested. You can see. Can you see here? You can see here. These are all the the surface roughness that is created. So this is the original building to be tested. So nearby, if this building is to be constructed here, the building must be surrounded with the many other buildings. So all such building have, and that atmosphere has to be, and the wind will be blowing from one side, and this particular round table, you can see a round table here. On the round table, this and this round table can be turned, 360-degree turning can be possible. So the wind is blowing, this wind will be passing through the entire structure, and the study will be conducted. Okay, the pressure tappings will be connected, the velocity will be calculated, the pressure difference will be calculated, and all the wind load parameters will be calculated, and the building will be permitted to construct. Okay, so wind load analysis is very important, and the wind tunnel is the instrument that is used for testing the building. So an exact situation will be created in this wind tunnel, and it will be studied. See, so this is the building. This will be studied. Then every part of the building, the pressure tappings will be provided, and the pressure difference will be calculated, velocity will be calculated. All this facility, you can see these are the different wind tunnel models. In our university, there's a wind engineering department, but that wind tunnel is different from that of the structural wind tunnel, because for us the building has to be our building. For a structural related setup will be different, because our structure is a cantilever structure. It is a, whereas aeronautical engineering, wind engineering, and sorry, the wind tunnel will be, the specimen will be horizontal, because the aeroplane have to test the aeroplane that is in the horizontal mode, but for us the building is in the vertical mode. Okay, so there will be a slight difference between the aerodynamic wind tunnel and the structural. Okay, so with this I will be completing the loading part of the this particular syllabus. Second unit actually, the second module will be completing. I think maximum one more class I will take to come do the calculations of the wind load and earthquake load. With I'll be moving on to the third module. Okay. Is it clear? Can we close it today?
Okay, ma'am.
Thank you.